Hi friends, in this video we'll learn exercise 1.1. We have learned the fundamental theorem of arithmetic and formula regarding HCF and LCF in the previous video, right? If you want to see that video, you can see my previous video regarding the fundamental theorem of arithmetic. Okay, let's get started. Here the question is, express each number as a product of its prime numbers. Okay, so we are given many questions. The first question I have taken here, that is 140, right? So this 140 we have to write as the product of prime numbers. Okay, now we'll see how we can write this. 140, all of you know that 140. How will you write 140 as a product of primes? 140 is an even number, right? Is an even number because the ending number is 0, right? So it is divisible by 2, right children? It is divisible by 2. So 2 will go on this to 140 and 2 goes on 14 7 times, 2 goes on 0 0 times, right? Then again 2 goes on 70 because ending number is 0. So it's an even number, right? 2 goes on 7, 2 3s are 6, right? 2 3s are 6, 6 plus 1 is 7. So this 1 can be the remainder here. So 2 goes on 10 5 times, right? So again we got 35. So ending number is 5. So it is divisible by 5. So 5, 7 5s are 35, right? So 140, that is the 2 into 2 into 5 into, if you want you can take one more 7. Till you get 1 you can repeat this. 7 goes on 7 one time, right? So this 140 we can write as 2 into 2 into 5 into 7, right? 2 into 2 into 5 into 7. That means we have learned the fundamental theorem of arithmetic, right? Fundamental theorem of arithmetic says that all the composite number can be factorized as a product of primes, right? So this 140 we have factorized as a product of primes. That is equal to 2 square into 5 into 7. Okay, so 140 we can write as 2 square into 5 into 7. Now we'll see the next question. Now the next question is 156. Okay, so same way 156 we can factorize like this. Ending number is 6, so it's an even number. So 2 goes on 15 7 times. 2 7s are 14 and 1 carrying, right? 2 goes on 16 8 times. So 78. So ending number is again 8. So it's an even number. So 2 is divisible in 78, right? So 2 goes on 7. 2 3s are 6. 6 plus 1 is equal to 7. This 1 will write here. So 2 goes on 18. 2 9s are 18, right? So it is 39. So which number can be divisible in 39? So you can see that is 3 because 9 plus 3 is equal to 12, right? So 12 is in the table of 3. So it is divisible by 3. This way you can check the divisibility test. That is, just add these numbers. 9 plus 3 is 12. So 12 is in the this 3's table, right? So it is divisible by 3. So next one 3 goes on 3 one time, 3 goes on 9 3 times. So 13 3s are 39, right? So again 13 1. Till you get 1 you can do this. Otherwise you can stop here also. Till 13 you will get the factorization, right? Now what is 156? How you can write 156? 156 is equal to 2 into 3 into 13, right? That is equal to 2 square into 3 into 13. 2 is repeating twice, right? So 2 square into 3 into 13. So 156 can be written as 2 square into 3 into 13. So it's factorized. Now the third question is 3825. Okay. Let us see how we can factorize this. 3825. Okay. So the prime numbers, you know that prime numbers are 2, 3, 5 and so on, right? So 2 will not be divisible on this 5. Isn't it? If the ending number is 5, 3825, 2 will not be divisible, right? So if it is an even number, it is divisible by 5. It is divisible by 2, right children? So ending number is 5. First we'll check whether it is divisible by 3 or not. Then we'll come to the 5. Okay, some rules we can follow this, then it will be anyhow. If 3 is divisible number, anyhow you will be getting 3, no doubt at all. But we will check. See, 3 plus, how we can check the divisibility of 3? 3 plus 8 is 11, 11 plus 2 is 13, 13 plus 5 is 18. So sum is 18, right? So this 18 is in the table of 3. Am I right? 18 is in the table of 3. So it's divisible by 3, right? So 3, because 18, sum is 18. 18 is in the table of 18 is in the table of 3. So 3 is divisible in 18. That means 3 is divisible in 3825. Now we can divide this number, the whole number, with 3. Okay. So 3 goes on 3 one time. 3 goes on 8. That is 2 3s are 6. 7, 8, right? 22. 2 is the balance. Then 3 goes on 22. 7 3s are 21. Then 21 plus 1 is 22. So this 1 we can write here. 3 goes on 15 5 times, right? So 1275. Again you check the divisibility. Right, see this. 2 plus 1 is 3. 3 plus 7 is 10. 10 plus 5 is 15, right? The sum is 15. Sum is 15. So that means it is divisible by 3. No doubt at all. Divisible by 3. Okay. So next one, we can divide this with the 3. 3 goes on 12 4 times. 3 goes on 7 2 times. Because 2 3s are 6. Right. Then 1. 3 goes on 15 5 times. 425. Again, check it again whether it is divisible by 3 or not. 5 plus 2 is 7. 7 plus 4 is 11. Right? 11. 11 is not in the table of 3. So it is not divisible by 3. Now we can take 5. Okay. Right from the beginning we know that 5 is a divisible number. No doubt at all. But here, there we can divide with the 3. That's why I have checked with the divisibility test of 3. Now here 5, it is not, 425 is not divisible by 3. Now definitely we can go for 5. It is divisible by 5 because ending number is 5. 5 goes on 42. 8 5s are 40, right? Then 2, 25. So 5 goes on 25 5 times, right children? 85. Now again 85. 5 times. 5 goes on 8 1 time. 1 5s are 5. 5 plus 3 is equal to 8. That is 3. 3 remainder. So 35. 5 goes on 35. It is 7 times. 7 5s are 35. Right? Now again 17 only because 17 is the prime number. 17 is a divisible number. 17 goes on 17 one time. So till you get this 1, you can try this factorization. Okay. Now you write. How we can write 3825? That is 3825 is equal to 3 into 3 into, how many 5s are there? 3 into 3 into 5 into 5 into, now 17, right? That is equal to 3 square into 5 square into 17. Now factorization of 3825 is 3 square into 5 square into 17.